Good afternoon, everyone. My name is Andrew.
My name is Aaron.
Waiting on
My name is Mason.
My name is Ernest.
Hi. Okay, and we're the capstone group for the Safety Systems Integration Project, and we're thankful that everyone is able to be here today. We'll be discussing our project scope, along with the problem statement and constraints, our preliminary research, design concepts, and decisions made based on our morph chart. Well, we will have a Q&A at the end, so please hold any questions until that time. Take it away, Ernest.
The client has requested the installation of a safety integration system in the mechatronics lab that is suited for the demonstration of concepts that were taught in class. Also, it should have a flexibility required for training in various environments. We are required to utilize components supplied by Omron Manufacturing Company. The goal is to wire and install the hardware devices. Then we move to writing and testing the codes used for the safety system. Then we proceed to the documentation of all information relevant to the successful completion of the project. Next slide, please. So talking about the scope of this project, we want to have an independent power supply for the safety system because in the event of having a power loss in the machine, we would want the safety system to have power to function as required. We want to connect the robotic controller to the safety system so we can have the robot physically stop moving when the safety system is active. Saying in the case of when someone walks within the range of the safety system, we want the machine to come to a complete stop. For added flexibility to switch between modes of safety, we want to create a human-machine interface program that allows us to change modes of safety by simply pressing a button. We want our wiring and installation of components to be done to industrial standards. And also, we want to document any limitation or restrictions that are found in the system. Next, please. Due to the current situation going on in the world due to COVID-19, we've have limited time to work on the installation of our components. And having a single power supply for the safety system will not work because the power draw required for the operation of the safety system is more than the single power supply that we have presently. Due to the safety system being used in different environments, we want to have a controller with mode switching suited for different safety requirements. Having an understanding of the varying requirements for different robots is vital for us in order to achieve a safe operating environment. Next.
Preliminary research. All right. So if you look up in your top left corner, we'll see just a small example of how the unit will be running. The CPU unit will be connecting and communicating with coupler units, and in return, they will be communicating with LiDARs, light curtains, and the robot controller. In your top right corner, this is Sysmax Studio. This is the software that we'll be using to program our entire project with. So in the bottom left corner, power calculations. For example, we have relay, intelligent tap, LiDAR, and safety PLC, and there's more in there. At the bottom there, we're running at roughly 6.2 amps. We actually have one power supply so far, and it's running at 4.2 amps. So what we will be doing is putting two power supplies in, one on each side of the lab. Bottom right, safety calculations. I mean, these are very important. I mean, we don't want anybody to lose a limb or potentially their life due to bad safety calculations. Yeah, next slide.
All right, and as for competitor information, which is really a part of preliminary research, while labs and educational institutions within Canada obviously have safety systems implemented, research into competition has indicated that there is a general lack of practical training and hands-on education available. An exciting aspect of our project is that the work we produce is intended to be used for the development of labs and practical training of future SAIT students.
Function analysis. So we'll just be going over how the system works. Starting up here at start operation. If the doors are on, and the doors are closed, just continue the operation. And if the doors are on and the doors are open, then they'll be communicating with the EtherCAT. And that would be the same for as if the doors were off, still communicating with the EtherCAT. Now what you're seeing next is the EtherCAT, the NX1P2, and the safety PLC communicating back and forth, sending signals to the robot controller. A small example of what would be going on in here is, does the LiDAR detect someone? If not, continue the operation. If the LiDAR does detect someone, are the light curtains triggered? No, continue the operation. If yes, stop the robot operation. And once light curtains are not triggered and the LiDAR is not triggered as well, return to operation and back to the start. Next slide, please.
Okay, so primarily we want to get rid of the doors on all of the robot work cells and use primarily light curtains and LiDARs to detect any interference that could come into the work cells. But as the doors could still be needed after safety calculations, we suggest a magnetic lock over the current door switches to be installed. For our warning system and mode selection, we are primarily going with an HMI system to keep it all organized, everything on one place, everything easily monitorable. For our wiring, it's very connected to the power supply, where we need 2 power supplies, each on both sides of the lab space. And we're going to primarily use Ethernet cables to do that, to limit the wiring to as best as possible. But we have the option of Bluetooth in the near future, possibly to be added. And along with that, the Ethernet cables can be well used to connect to our programming software, Systematic Studio. Our communication protocols are the safety on Ethernet, the safety over EtherCAT, and the Ethernet. And for our safety relays, we need to be using normally open, held closed relays to make sure if any power outage happens, any loss of power, the robots will stop and cease movement, everything will be safe. Next slide, please. This first photo is a multi-beam system that has very limited beams in comparison to the light curtains. So you could easily stick your arm in and not be detected, and a robot could just come up and chop it off. It's very ineffective. Below that is the safety mats. They are pretty good, but they lose durability, and along with that, their reliability just plummets. So we're not going to be using those. Along with that, we have one cell that needs to go all the way around the lab space. So we need to have some mirrors to redirect the light curtains. We're running that through 45-degree mounted mirrors, some top and bottom brackets, an outside column mounted mirror, or some floor mounted mirrors. Next slide.
And as for the relays, if you look in the middle there, we have an image of one of the robot controller innards. That's actually our robot controller dot. But anyway, we considered a few different designs, such as one to house a single relay, a double relay, and a triple relay. In the end, we decided that it was best to go with an L-shaped triple relay bracket, because the L shape if you look in the top right, we have a model there. The holes in that back panel there, they actually allow the relay bracket to be mounted into the robot controller using existing screws. So there is no alteration to the robot controller itself, except for the removal and replacement of its own screws. In the bottom right there, we have some ideas for the LiDAR bracket so that we can mount it up off the ground. And we even have, we're having a little bit of trouble with the camera here because of the trans-dimensional portal allowing me to be in the lab while I'm actually at home. But anyway, it's sort of got this prototype here. It mostly showing up. They've got some reset. Sorry, it's not working very well. I'll just move on. In summary, today we've delivered our problem statement. We've discussed our client requirements based on the scope and safety considerations. There'll be ongoing research to make this project possible. We really hope to succeed and are pretty optimistic at this time. We've also taken a look at the morph chart and our design concepts. What's next, you might wonder? We're just about to get into actually physically wiring everything, which is very exciting for us. We've just received the additional input modules that are required to facilitate much of that wiring. And we're also working on the power diagrams to plan out the wiring so that we don't make any mistakes. Obviously, everyone wants to avoid mistakes. And so that is the end of our presentation. Thank you everyone for being here and for listening. And if you have any questions, we'd be happy to try and answer them.
I do actually have a question.
Okay.
Based on your function analysis, you're using the LiDAR to detect if somebody's close to the door, and the light curtain just to detect if something's passing the door or like walking into the work cell. As far as I understand, you can determine using by looking at the sequence how the light curtain is broken, if it's a human being or if it's, for example, a Robotino that is trying to access the work cell. How are we going to implement that?
Well, the LiDAR is sort of, we're anticipating it being kind of a warning signal. And then if the light curtain is breached, then it would be an absolute yes, the system must shut down or the robot must stop now. As for Robotinos, we don't particularly want them going in the cell either. They could be a hazard to the robot, or the robot could be a hazard to the Robotino, causing damage in either direction. And so, yeah, frankly, Robotinos would not be welcome in the cell while the robot was in actual operation. And so in the event of a Robotino wanting to enter the cell to pick up a product and or deliver a product, we would want the robot to halt its procedure while that was happening.
Is that gonna like stop the program that is being executed, or is it just detecting if there's no movement?
It would pause the program that was being executed and then hopefully pick up from where it left off. And sorry, what was the second part of your question there?
It was just asking if it was interrupting the program that is currently running or the routine that is currently running, even though like the robot wouldn't be moving in that moment.
Well, that's yet to be determined, really. There's a lot of aspects that we're not 100% sure of yet. As we indicated, there is further research required to successfully complete this project, and that would be something we would take into consideration for sure.
Thank you.
Thank you. Are there any other questions?
I'll just add a side comment based on my experience with curtains. It's important, like Damien was saying. Sorry, I'm not sure if I pronounced it correct. I experienced we had an issue where not at Big Chief, but in a different place, where production was constantly being interrupted because as the product went through, the curtain would realize the product. So it was a matter of adjusting the heights in order to allow products to go through, or to allow the item that is authorized to go through without having people actually walk through. And that became something that was a fine dance where we had to do vertical protection as well as horizontal protection, just so you guys know.
Yeah, that's definitely an interesting point. At the same time, you don't want the light curtains to be too high because a devious individual could decide that they were better than the or smarter than the system and try and sneak in under it. But yeah, I think like the idea is that the LiDARs will sort of detect proximity as well, so they will have some idea of where an object is and how it's interacting with the system.
Yeah, just as you guys do it, just try to hack it as much as possible, because for sure, like you said, people will try to penetrate the spots that they know are loose spots, but at the same time, you don't want to interrupt production, because the whole point of everything is to make sure that production flows nicely.
I think that would come down to scheduling and planning between the two different systems, sort of cooperation, that kind of stuff. But thank you. Thank you. Well, if no one else has any questions, thanks again for everyone for being here. We are definitely very grateful for your attendance, and thank you to SAIT and our client and advisors for helping to make this possible.